This comes out of section 5.1, vertical asymptote. To start off this example, we're going to look at the function y equals 1 over x squared at its one kind of interesting point or interesting place, which is where x gets close to 0. If I didn't know what that looks like, I might go all the way back to table of values, say x and f of x, and put in some numbers. So relatively small number is 1. Well, 1 over 1 squared equals 1. So I could plot that on my graph. Turns out this function is even, meaning that it gives you the same answer for positive 1 as it does for negative 1. So let's put those both in there. Now if I put in 0.5, whether positive or negative, if you do 0.5 squared, you get a quarter. 1 over a quarter is 4. So this graph, if I'm kind of plotting points here, I've got the point at 1, 1, negative 1, 1, and I've got 0.5 comma 4, negative 0.54. If I do, progressively smaller and smaller numbers like 0.1, get carried away, do 0.0001, etc., you can see that these numbers are going to, for the y value, get really, really big. I get all the way up to 100 already here. This next one is, a whole bunch of zeros after here. How many zeros do I have? 1, 2, 3, 4, 1, 2, 3, 4, 6, 7. Some ridiculous number, 100 million. And so what you find is that as x gets close to 0, this function approaches infinity. That this graph just goes up very, very steeply on both sides of that. And it turns out what we actually have here is a vertical asymptote at x equals 0. We have an imaginary line that this graph approaches closer and closer and closer. The rest of the graph, not that important to us for this example, but it looks something roughly like that. And you have this, one way to be able to say this is to say the limit as x approaches 0 of 1 over x squared is infinity. And that's really kind of what we're getting at when we talk about vertical asymptotes. In this case, this function, f of x, has a vertical asymptote. At x equals 0. Clearly it's not continuous there. You have to lift your pencil to draw the rest. If you, pardon me, don't remember our continuity definition, you basically said if you're continuous at a, at x equals a, then f of a has to equal the limit as x approaches a of f of x. So the left side and right side limit have to exist, and they have to equal the function at that point. Well, in this case, the left side, right side limit are both giving me infinity, but I can't say that the value of 1 over 0 squared is infinity, because it isn't. But this idea of finding the limit and realizing that that limit approaches infinity is going to allow us to find vertical asymptotes for all kinds of functions, because basically, if I forget about that example for the moment, if I have vertical asymptote somewhere, on one side, or potentially on both, I'll either be approaching infinity or negative infinity. So just to give you some various pictures of that, I could be looking like this, up and down on the two sides of it. I might only be defined on one side of it, but as long as on one side of my asymptote I'm approaching infinity or negative infinity, I have myself a vertical asymptote. So we'll look at that again a little bit further in the next example.